Hi, I'm Prof and welcome to Chemistry Matters. And today we are going to be having a look at some solution stoichiometry. The reason that we're going to be doing this is because some of you watching this may go on and end up in a job in something like a hospital lab, where you've got to make up particular solutions of drugs, antibiotics, those sorts of things, and it's kind of important that you do that properly. So let's, without further ado, start off by having a look at how we go about diluting solutions to make solutions of known concentrations. That's a really, really common aspect in particularly things like analytical chemistry, and as I said before, when you are working in sort of hospital labs or pharmacies, those sorts of places. So let's say that we have got a solution of an antibiotic and its concentration is 2.50 times 10 to the minus 3 mole per litre. So that is our antibiotic. And that's known as a stock solution, and that is basically one which we dilute to make the solutions of concentrations that we actually want. So let's say we have this stock solution of our antibiotic, and we want to make 200 milliliters of a solution of the antibiotic that is 4.00 times 10 to the power of minus 4 mole per litre. So how do we do this? Okay, so hopefully you can see that what it is that we're doing is taking our so-called concentrated stock solution and we are going to dilute that down. So we're going to take some of this and we're going to dilute it down with a certain volume of water to make 200 mils of our solution having the concentration that we want. So how do we go about doing this? Well, this is a stoichiometry problem, and being a stoichiometry problem, we're going to use one or two possible equations when it comes to solving this, and in this case we only need the one equation, because let's see what it is that we're given. What are the data that we've been given? We've been given a volume, and we're given a concentration. So hopefully, as I say, when you are sitting there looking at your stoichiometry problem and don't know where to start, you look at your data and figure out which of those two stoichiometry equations you're going to be using. We're given a volume, we're given a concentration, so therefore chances are we're going to be using this equation here, okay, C equals N over V. Because there is our volume and there is our concentration. What can we get if we know those two things? We can get ourselves an amount, a number of moles. Okay, so let's think this through. Here is our final solution here. And what we can find out from the data that we've been given is the number of moles of antibiotic in that final solution. Now, where did that particular number of moles of antibiotic come from? It came from our stock solution here. So that's the reasoning that we're going to be using. We ultimately want to find the volume of this that we need to dilute down to get this. That's what we're after, okay? So it's kind of going to be a two-part calculation. In the first part, we're going to be calculating the number of moles of antibiotic. Once we know the number of moles of antibiotic, we then know the number of moles and we know the concentration. We can then get the volume that we require in order to dilute down. So here goes. So the first thing that we're going to do is say that the number of moles is equal to the concentration times the volume. The concentration being 4.00 times 10 to the minus 4 mole per litre, multiplied by the volume here, given in mils as it always will be, just to trap you. Remember, we need that in litres, so 0.200 litres. And so the number of moles there is going to be 8.00 times 10 to the minus 5 mole. And again, just a little check just to make sure that you've rearranged this equation correctly. Remember, your units should work out. Mole per litre multiplied by litres. So the per litre cancels with a litre. You end up with the unit of mole, which is what you want. So we've done our rearrangement correctly. So this is the number of moles of antibiotic that we want from our stock solution. That's what we want. Okay, so in terms of our stock solution, what do we now know? We know the number of moles that we want from it, and we know its concentration. So if we know a number of moles or an amount, and we know concentration, we can then get a volume, can't we? And that's going to be then the answer to our question, essentially. So again, if C equals N over V, then V, the volume of our stock solution we're going to require, is equal to N over C. Here is N, here is the number of moles that we want, 8.00 times 10 to the minus 5 mole. Our concentration, we're given here, 2.50 times 10 to the minus 3 mole, per litre. And that is then equal to 3.20 times 10 to the minus 2 litres. And again, we can check and make sure that we've rearranged this equation correctly. We check our units. We always check our units. Okay? The unit of mole on the top line is going to cancel out with the mole on the bottom line. We end up with a litre to the minus 1 on a bottom line, 1 over litre, or in this case 1 over litres. That gives you litres. That's the unit of volume. So we have rearranged our equation correctly. So there's our answer. What we do is we take our stock solution, we take 3.20 times 10 to the minus 2 litres of that, and that is in fact equal to 32 millilitres. So if we wanted to prepare the particular solution of our antibiotic, we take our stock solution, we take 32 mils of it, and we dilute that then to a volume of 200 mils. That was what the question asked. The total volume of our final solution was 200 mils. So that's how we go about doing that, which is kind of nice. It's a good sort of little exercise in using this equation that concentration is number of moles over volume. I said that was a two-part calculation, and it was. In the first part, we calculated a number of moles, an amount. And in the second part, we used that number of moles to calculate a volume. So is there a quicker way of doing this? And the answer is yes, but you've got to be careful. So there is an equation that you can use to calculate dilutions. And this equation, C1V1 is equal to C2V2. This is an equation that I personally wouldn't use. A lot of people do, but you've got to be aware of the possible problems with this. But let's go through the calculation anyway and just show you how to go about using this. So remember, what we had, or what we wanted, was a solution that was 4.00 times 10 to the minus 4 mole per litre, and we wanted 200 mils of that. So all that we're doing is doing this now a different way. We're saying C1V1 is equal to C2V2. We want to find V1. We want to find the volume of our stock solution that we're going to need in order to make up this final solution here. So let's rearrange this equation. The way that we do that is divide both sides by C1. That gets rid of C1 on this side, it puts it over to here. So therefore, C2 times V2 over C1 is equal to V1. That's going to give us our volume directly. And so let's do that. So C2 is 4.00 times 10 to the minus 4 mole per litre multiplied by V2. Remember, millilitres no, litres yes. 0.200 litres, divided by C1, and C1 was the concentration of our stock solution originally, 2.50 times 10 to the minus 3 mole per litre. And if you do the calculation, you have to get the same answer, okay? And that comes out as 3.2 times 10 to the minus 2 litres, and that's the same thing as 32 millilitres. Okay, why don't I like this equation? I don't like it because you can get away with not using SI units, which, yes, is complete anathema to me if you hadn't otherwise already have guessed. So what you can do, and I shouldn't really tell you this, is that you can use volume in milliliters here and volume in milliliters here, and you'll end up with volume in milliliters there, but that goes against everything I stand for in terms of SI units. So with that proviso, this is a quicker way of doing that same calculation that we just did, okay? Ultimately, I'm sure your examiners are not really going to care which way you do it as long as you get the correct answer and you show all your working. That's always really, really important in any stoichiometry problem. Okay, so let's finish up by looking at a very quick solution stoichiometry question. We have our solution of sodium iodide and we've got 10.0 mils of that, and it has a concentration of 0.200 mole per litre. And what we want to know is what mass of sodium iodide is contained in that particular solution. So we have a stock solution of 0.2 mole per litre. We take 10.0 mils out of it. What mass of sodium iodide is then contained in that 10 mils? So we look at the data that we've been given. We've been given a volume, we've been given a concentration, so we know V, we know C, so therefore chances are we're going to be using good old C equals N over V, or a rearrangement of that, and that's what we're going to be doing because we know volume, we know concentration, we need amount. So therefore N is equal to CV. So the number of moles of sodium iodide that are going to be in that 10 mils, we can then get from the concentration, 0.200 mole per litre, multiplied by the volume. This again is in mils, we want it in litres, remember, 0.0100 litres, and that is equal to 2.00 times 10 to the minus 3 mole of NaI in that 10 mils. Now the question asked not for the amount, but it asked for the mass. So therefore, like any stoichiometry problem, we've got to figure out which equation to use. Now we've got N and we've got a chemical formula, so we can get a molar mass, and then from that we can get a mass. So therefore we're going to be using good old M, is M over N. So therefore we do our calculation, so the mass is equal to the number of moles, which is 2.00 times 10 to the minus 3 mole, multiplied by the molar mass of sodium iodide, which is 22.99 plus 126.9 gram per mole. Again, those numbers coming from the periodic table. And if you do that calculation, it comes out to a nice pleasingly round number of 0.300 grams. So that is the mass of sodium iodide that you're going to have in 10 mils of that particular solution. Okay, so again, we've gone through a couple of examples of solution stoichiometry and how to use that equation, the concentration equation, C equals N over V. We've used it in a variety of guises here, and hopefully it has all made sense to you, and we'll see you next time.